All right, moving right along. We're at about the halfway point through our chapter, so that's good news. We do have a little afternoon sunshine, so I don't think it'll cause too much glare. I think we'll be okay. But I do have a quiet dog in this video, so that is the reason I decided to go ahead and move forward and get this done yet this afternoon, because my dog is nice and quiet. Of course, I've probably just jinxed that. We will see. So 6.4 is adding and subtracting with, now we're looking at denominators that are not the same. So we left off in 6.3 looking at how to find a common denominator. So remember, those steps were to factor each of our denominators into primes, and then we want to find the common denominator, mathematically known as the least common multiple, or LCM. And we need to make sure we include each factor and that we take the bigger string. So if there's one number that shows up more than once, or the larger exponent, however you would like to think about that. Sometimes when I say bigger string of numbers, it connects better with students as it's written and expanded out. So our first example has no variables at all. I tried to keep it kind of back to our K-12 experiences here. So if we break down 14, we get 2 times 7. And if we break down 8, we get 2 times 2 times 2. And so when I identify that common denominator, when I look at how this has 1 2, but this has 3 2's, take all 3, take the bigger string, and then we need a 7. So step 1 now is finding that common denominator, and then I'll show you what we're going to do with that after. 2 times 2 times 2 is 8, times 7 is 56. So that is going to be our new common denominator. So some students prefer to work down, others prefer to work across. It kind of just is personal preference. I think your book will show you examples both ways if you look at the electronic version of the book. Let me give myself just a little bit more space here. All right, so I'm going to have something over 56 plus something over 56, and then when I add those two answers together, my denominator will stay 56. So now we're going to do something where we compare. What do I have to multiply this 14 by to come up with the number 56? Or 14 goes into 56 how many times? What is that multiplier? And the answer in this case is 4. So I need to multiply the bottom by 4 to get 56. And whatever I do here to the denominator, I also need to apply to the numerator. So in essence, this really isn't changing the value of the fraction because you're multiplying by a number over itself. And so 2 times 4 here is 8. And just because I have all these colors, I can use them. We're going to do the same thing with the second fraction. How many times does 8 go into 57? Or 8 times what number is 57? 56. Sorry about that. My answer is clearly 7, so I've got that in my head. So 8 times 7 is 56. 1 times 7 is 7, because whatever you do to the denominator has to be done to the numerator. So 7 is going to go right here. And now that I have a common denominator, I can apply this operation. 8 plus 7 is 15. And that cannot be reduced. 15 over 56 is my final answer. Is there a scenario in which this could be reduced? Absolutely, and we'll build, and those will come up eventually. Let's try it again. Our second example is 3x squared over 10 plus 2x over 15. And so when we try to find our common denominator, you might know what it is right away. It's going to be 60 because you might just have a really good sense of your multiplication skills and your facts there, and you just might see it. What happens if you don't see it? Well, 10 is 2 times 5. 15 is 3 times 5. Oh, sorry, it's not even 60, it's 30. Look at that. So if you thought 60 right away, that would work. You'd have to reduce in the end. It's not the lowest common multiple. 30 is going to be our answer here. So LCM needs a 2 times a 3 times a 5. We don't need 2 5s. Notice how this just has 1 and that just has 1, so that takes care of it. You don't need 2 5s in the mix. So then our answer is 30. So I'm just going to set it up with that common denominator. And now I'm ready to kind of play the what's missing game. What do I need to multiply? So I look at this 10, and I look at that 30, and I think 10 goes into 33 times. So I have to multiply top and the bottom of that fraction by 3, which will give me here 9x squared. And then I'm going to do, what do I need to multiply 15 by to come up with 30? And 15 goes into 32 times. So I'm going to multiply both top and bottom by 2. There's no reason I used x's instead of dots. I'm not trying to imply that it's a variable. And so 2 times 2 here is 4x. And so 9x squared plus 4x looks like that. And nothing can be reduced. So I hope you're kind of seeing the pattern and the steps that we need to follow. At any point you can stop and try the next one if you'd like on your own. And then we'll start creating problems that require you to factor in a different way, and we'll look at some of those as well. So we are building our skills here. My next example has a subtract, but we know that's not going to change too much of our process. So we've already broken 8 down once today. 8 is 2 times 4, which is 2 times 2. So we've got 3 2's and an x. 12 is 4 times 3, or 2 times 2 times 3. And then we have 2 x's. So my common denominator will need 3 2's. A 3, and x squared. So 8 times 3 is 24x squared. So I can go ahead and put that right here, and right here. Okay. And now I'm going to say to myself, what do I need to multiply by? Or how many times does this divide evenly into this? So I can color code that so you know kind of where I'm looking. 8 goes into 24 3 times. And I have x to the first power here, but I need an x squared. So I'm missing an x. So I need to multiply top and bottom of my fraction by 3x. And so 3x times 7 is 21x. Just want to clean that up so that it doesn't look so messy from your perspective. Let's look at the second term. 12 divides into 24 2 times, so I'm going to multiply top and bottom by 2. And I need an x squared, and I have an x squared, so that's really all I need to multiply by. So 2 times 5 is 10. And now my denominators are all good to go, so I look at my two numerators, 21x minus 10. I have no like terms there. So that's it. You just kind of extend that piece right there so that you can get everything on the same fraction, and you're done. Let's do it again, and I think we're at the point where we're gonna start to factor just a little bit. So yes, indeed, at least one of our problems here. So we have 3 over x plus 2 plus 5 over x squared minus 4. So you didn't think we were going to have a lesson where we didn't get to factor. I wouldn't want to disappoint anybody here today. So this second fraction here does factor to x plus 2x minus 2. So my least common multiple, or my common denominator, does need one of these, just one. It needs an x plus 2 and an x minus 2. Every factor needs to be represented. So I know this looks much more difficult than just regular constants, but the process really isn't changing. So I'm going to write x plus 2x minus 2. And then this is a positive, x plus 2x minus 2. Don't try to save paper on this lesson, that's for sure. And then x plus 2, x minus 2. All right, and now we play that same kind of what's missing, what do I need to multiply by? So I'm comparing here to here. What's missing? I need to multiply x by x minus 2. That's the piece that's missing. And you know from the previous examples, whatever you do to the denominator, you have to do to the numerator. So I need an x minus 2 here and an x minus 2 here. So here I'm going to have 3 parentheses times x minus 2. Switch up your colors. Here I have x squared, or I have x plus 2x minus 2. Sorry, I would leave it in the factored form. Here I have x plus 2x minus 2. This is the common denominator. So you don't have to do anything. Keep the 5 and just rewrite it. The 5 just stays the same. And now we're going to add all of that together. So you have some options. You can multiply this through and write the extended out right here. You can kind of go off to the side and mess with it and put everything together. However you choose to do your work. We could just put it right up here. We have 3x minus 6 if I distribute that. And so now I have a negative 6 here and a positive 5 here. So 3x plus 6 minus 5 is 3x plus 1. And so that becomes my numerator in my final answer. All right, are you ready? There is something that you are going to experience. This is the last little trick, and then the problems, of course, change in style, but that's the gist of it. The only last little trick that you might see is something called opposite factors. Opposite factors are like this. And we looked at this when we were simplifying a few sections ago. This works a little bit differently. Same idea, but it's going to have a little bit of a different impact. So you can see here that these two are almost the same, but once again, they're switched in order. So here the negative goes with the 4, and here the negative goes with the x. And so the idea is that you would like to create a situation where that would match, where they would be the same factor. And so what you can do is you can actually pull a -1 out of this denominator. And when you do that, this 4 will become negative, and the x changes signs to a positive. And so then we do just kind of a big switcheroo. This stays the same. I'm going to rewrite it. But that negative right there is going to cause that positive to create a subtract. And then I'm going to reverse the order here. So I pull out that -1, and that negative changes this positive to a negative, but now it is apparent that your two denominators should match up, and they are the same. And so now that kind of makes it easier in the sense that you don't have to look for a common denominator. And so your numerator, you just have to put this together. Your numerator now is x minus 9, and your denominator is x minus 4. And don't get excited and actually like accidentally slash those x's out of there. That is your final answer. All right. Hey, we got through a whole page of notes. Let's see what's waiting for us here on the other side. Let's do one that looks like this. Oh, forgive me. I have an example here that looks good in theory, and then I have a big cross, like a big X through it. But I want to see, it's a perfect example to illustrate that opposite factors. So we're just going to keep moving forward here with this and hope for the best. So let's look at this one. All right, this is a perfect example of how this can work. All right, we need a common denominator, so we're going to factor. So I'm going to factor x squared minus 25 to x plus 5, x minus 5. And then I kind of noticed, well, gosh, this is super similar to this, but again, it's backwards. So I am going to do a little trick, and I am going to change this to a subtract, and I am going to rewrite that as x minus 5. And so that's what that opposite factors can do. You just switch this, and you're good to go. All right. So what is my common denominator? It looks as if I am going to need an x plus 5 and an x minus 5. And that's going to be a minus. So I will need an x plus 5 and an x minus 5. And then I'm moving way over here. Oh, I hope I still am on camera. X plus 5, x minus 5. All right. This is this. And so you don't have to multiply by anything. This x I can just rewrite. I didn't color code that, please forgive, because I knew I wasn't going to have to multiply by anything. This piece right here, when I compare, what do I need to multiply by? This guy right here looks like it's missing an x plus 5. So I'm going to write right here x plus 5. And I'm going to write right here x plus 5. So kind of depends once again how you want to do your scratch work. We definitely are going to have some simplification to do. Be careful because that negative is going to apply to everything. So we can write this right here, 3 parentheses x plus 5. And then I probably am going to come down here where I have this big workspace, And I'm gonna work with everything in the numerator, and then I'll just put my final answer right there. So, forgive the mess. You can always go back and rewind the video. But I'm gonna write x minus 3